Hello, and welcome back to the Reconciliation Project podcast, where we are formed by faith and informed by science. I'm Hunter.
And I'm Sam.
And in today's episode, we're going to be looking at the question that people have asked for thousands of years, and that being, how did things start? And we're going to be looking at the two predominant ideas over the past 300 years to answer that question, that being the eternal universe idea and the Big Bang Theory. So if you want to start us off with the eternal universe idea and how we kind of progressed.
Yeah, absolutely. So historically, this surprises a lot of people given how prevalent the Big Bang Theory has been over the past 100 or so years. But historically, the majority of humans on the planet have thought that the universe always existed, that the universe was eternal. This goes back basically since ancient Greece, with Aristotle and Heraclitus believing that there always was a universe. There was not a beginning. Everything just always was and always has been. And that's still thought by a few scientists today. But it was widely accepted until the mid-1900s, which is when we saw a major shift. But originally, the only people who thought that there was a beginning were theological thinkers from the Christian community who held to the idea of creation as described in Genesis. But when we do start to see that shift, that started happening, I would argue, a little bit into the 1910s with a man named Vesto Slipher. He observed that stars and galaxies looked like they were tinted red, which was actually also observed by Edwin Hubble later on. But why does that even matter? What does that have to do with whether or not the universe is eternal or not? Which, glad you asked. But that does back us up a little bit, and we have to talk about something called the Doppler effect. The Doppler effect was first discovered by Christian Doppler in 1842, and you can actually most often hear this with car sounds or an ambulance going by. You can notice that the car sound or the ambulance sounds slightly different when it's coming towards you versus when it's moving away. There's a joke that a friend of mine tells that uses a car sound to replace the word now, and it sounds like meow, which is what a classic race car sounds like, right? But you can recognize that the very beginning of that car sound is slightly different than the end of that car sound, which is what we recognize as coming close and then coming away. What's actually happening with sound waves is that when a sound wave is coming towards you, or the thing that is making the sound is coming towards you, the wavelength is getting shorter. But when it's moving away, wavelength gets longer. And that coordinates with the pitch of the sound moving away. This actually also happens with light. Light and sound are both waves. And in the visible light spectrum, where you're talking about your rainbow colors, Roy G. Biv, the longer wavelengths and shorter frequencies are coordinated with the red hue in the red section of visible light. Whereas in the shorter wavelengths or higher frequencies, you're seeing more blue, which is called redshift and blue shift, which is what Slipher and Hubble were seeing, but they didn't recognize it at the time.
Yeah, so that kind of moves us into the early 1900s, where various scientists in their experiments and their studies, they found evidence for the universe expanding, which is what they were seeing with this redshift and blue shift, but they didn't know what that meant. But building off of what they had found and doing their own studies, they found pretty conclusive evidence that the universe was expanding somehow from a central point.
Exactly.
And in the mid-1900s, some other physicists proposed the idea of cosmic background radiation, which at this point, the Big Bang Theory had become more of an idea. And cosmic background radiation is essentially the leftover energy and light from the Big Bang. So the idea is if the Big Bang actually happened, we would see this cosmic background radiation somewhere, somehow. And in the 1960s, this was accidentally found. They accidentally found this background radiation, which kind of solidified the movement from the eternal universe idea to the Big Bang Theory. Mm-hmm. And we'll notice, if you look into this transition from the eternal universe idea to the Big Bang, that scientists were initially really hesitant to accept it. Because initially there was just the idea of the universe expanding, which had to show there being a beginning, which I think you were going to get into.
Yeah, actually. So going back again to kind of that timeline that you gave, what Slipher and Hubble were observing with this red and blue shift was implying that these stars, galaxies, whatever, were dynamic. They were moving. And so when you play that backwards, because the majority of what they were seeing was in the redshift, meaning it was moving away, if you play that backwards logically, you're seeing things come really, 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 really close together. And in the context of the Big Bang, this is what's referred to as the singularity. It's an infinitesimally small, infinitely hot, and infinitely dense point, so to speak, where all matter was contained. At some point, we don't really know what, we don't really know how, whatever. Scientists are still all over that problem. The singularity, quote unquote, burst, and the universe expanded very quickly and has since slowed down in its expansion. As the universe continued to expand, scientists argue that it cooled because when you get something that's really dense, it tends to heat up. We see this with states of matter, where if some atoms are very densely packed together, they do have some friction between them. And so the denser it is, the more friction is happening, and that causes heat. But as the universe continued to expand, scientists argued that it cooled, which allowed atoms and matter to actually fully develop, which is the central idea behind the Big Bang and still has pretty wide acceptance today.
Yeah, and let's keep in mind here that what I was getting into before, when the idea of the Big Bang was first being proposed, when the idea of the universe having a beginning was being proposed, because if you go down the Big Bang route, you have to acknowledge the universe had a beginning. And scientists didn't want to acknowledge that because as we talked about at the beginning, the idea was either the universe is eternal or that God created it. And if you propose that the universe had a beginning, you get into either you have to acknowledge God or you have to find some other way that it formed, which obviously that yielded us the Big Bang Theory. But the idea for the eternal universe idea was, well, you don't need a creator. If it's always been there, it doesn't need to be created. So historically, that was the idea, either no creator or creator. But as we progressed and as physics showed, yes, the universe had to have a beginning, no doubt, no question. Eventually, they got on board, but it took a while. They were very hesitant to get on board with that, but eventually they couldn't argue with the data that they get from physics. That
implying that there was a beginning.
Yeah, that pretty conclusively showed this beginning for the universe. So as we think about the Big Bang Theory, if you go into a science classroom, or if you read a science textbook, or if you go to the Smithsonian Museum, you'll find the Big Bang Theory as the well-accepted model for how the universe came to exist. However, there are some issues with the Big Bang Theory that have to be considered, and physicists have considered these issues in the past. And I'll be completely upfront, I'm not a physicist, you're not a physicist.
Yeah.
So all of this we don't entirely understand, and we're certainly not the authority in physics. But what we're gathering in terms of these issues is what other physicists and other scientists have shown are issues with the Big Bang Theory. And it starts with the singularity problem. Models in physics, cosmological models, when we talk about cosmology, is talking about the origins of the universe. We're not talking about cutting hair. That's cosmetology, not cosmology. Cosmological models cannot describe the singularity, what that would have looked like, how it would have worked. They cannot describe the singularity. Additionally, mathematical equations can only describe what happens after the expansion begins. So in that 0.0001 of a second after the initial bang is when mathematical equation can start to work. But in that singularity, they don't work. Ultimately, physics doesn't work and breaks down in the singularity point. So the idea is, okay, physics doesn't work. So does the beginning of the universe follow the origins or the laws of physics or not? But because they can't describe the singularity, there's really no way to ultimately
argue what it was or how it burst in the first place.
Right. There's really no evidence for the singularity other than the idea of everything had to have gone back to a single point. So while the evidence in physics is strong for the universe expanding, if you reverse that, it could go back to a single point. There's no way to actually describe what the singularity would have looked like or what it would have been. There's also what is known as the horizon problem, which is simply taking into account when you look at the universe as a whole. The universe is very uniform across in temperature, density, and background radiation. For that to be true, all of the points of the universe had to be at the same point in the past. And this sounds okay with the Big Bang because everything was at one dense point. However, when you look at 2 points across the sky and across the universe, we start to get into some issues. The universe itself can't expand faster than the speed of light. So it's impossible for 2 points on opposite sides of the sky to have been at the same point. Even like the 13.8 billion years of time isn't enough time for those 2 points to have connected.
You would see a line somewhere that would imply, okay, that's where the universe has gotten to.
Yeah. And honestly, this one is kind of not entirely clear to me because, like I said, I'm not a physicist. But the basic idea is everything is, because we talked about the cooling, everything is pretty uniform in temperature and density. So they would have had to have been together at some point in the past, which with the Big Bang, we see that. But with the horizon problem, that explosion probably would have thrown that off. And then there's also the flatness problem, which takes into account that the universe is remarkably flat and that matter and energy are observed in perfect balance. And the idea of this is that without fine tuning, this is an impossible thing to result from rapid expansion. We would see some imbalances here and there without something controlling, for lack of a better term, the expansion, the rapid expansion. Because when we're talking about expansion, we're talking about very, very fast, within a fraction of a second expansion. Because the idea of the Big Bang, like bang is kind of a misnomer because it immediately links us to explosion. It's not really an explosion, it's rapid expansion. And the best way we can acknowledge or explain that is through bang.
Yeah.
But either way, that rapid expansion, this bang, wouldn't produce this perfect balance that we see in a flat universe without having some sort of precise fine-tuning.
And we'll get into fine-tuning later on as well. That comes in a lot with the idea of creator and intelligent design, which we'll cover in a later episode.
For sure. And there's also the magnetic monopole problem, which this also getting into what a Big Bang can and can't do. High energy conditions of the early universe, according to physicists, would have resulted in the formation of particles with a single pole. And when we're talking about monopoles, think about a magnet. It has two sides, a north pole and a south pole. The north and south pole can connect, north and north repel, south and south repel. So think about a magnet. There's two ends, north and south. The idea is that the Big Bang would have produced these particles that only had either a north pole or a south pole, not both. And physicists have found no evidence for these particles in existence. They've found no evidence that they could be produced, and then they have never found any of these monopoles. Everything is found to have that north and south magnetic pole that we were talking about. Then there's the issue with quantum mechanics. The theory relies heavily on Einstein's theory of general relativity, but it fails to take into account the rules of quantum mechanics that would have took place in this singularity and in this expansion. There's the concepts of dark matter and dark energy that the Big Bang Theory relies heavily on as well. And these are essentially unknowns. They're unknown forces that are not testable, and they are essentially some things, because we don't know what they are. And they are things that cause certain things to happen in the universe. I know that's a little confusing, but it's not really well understood what they are or what they do.
Sounds a little bit like a metaphysical force, so to speak.
A little bit. There's very mysterious forces, what they refer to them as. And these concepts are used to explain the structure, rotation, accelerating expansion of the universe, but they're purely theoretical. There's no evidence that we can go and observe. There's no way we can test for their existence that I know of. And so the idea is these forces, these mysterious forces, are what's driving what we don't understand how it works.
Which, from a Christian standpoint, sounds an awful lot like God's guiding hand.
Yes. But in the scientific side of it, where we don't
Acknowledge that,
we consider dark matter and dark energy, which is driving things that we don't know how it works.
Yep.
So it's, okay, we don't see how this works. It must be dark energy or dark matter.
Yep.
And I'm not trying to say dark matter and dark energy don't necessarily have a reasonable scientific basis, but
the argument for them seems very similar to what Christians believe about God.
Yeah. There is the issue that kind of comes out of this dark matter, dark energy thing. Not really come out, but it's what actually makes it possible, according to physics, is the accelerating expansion. And that there is evidence that the rate of expansion for the universe is actually accelerating, which is contrary to what we might expect from the theory based on the laws of physics. We would think that the universe would actually be slowing down because it did initially slow down. But now the idea is that the universe is actually expanding faster
than it was before,
which physicists can't explain why that's happening, so they attribute dark energy to what's actually causing this to occur. And then lastly, there's more of a philosophical problem that I'm sure some of you may have heard, and that is the before time zero issue. The theory does not and cannot explain what happened before time zero or before the Big Bang. It doesn't get into how that energy came to existence, because the theory requires pre-existing energy and pre-existing space. Something was there before the Big Bang happened, but there's no explanation as to how that came into existence. And the theory doesn't attempt to explain this. I think this is one thing that I've noticed in Christian circles when they're trying to discount the Big Bang Theory. They're like, oh, the Big Bang Theory, what about where that came from? Well, the theory doesn't ever try to discuss that.
Mm-hmm.
The theory doesn't try to discuss where it came from, because if it did, they couldn't explain it.
Yeah.
And they don't explain it because they can't. So the idea is either someone created it or it was always there. So at the end of the day, you have to accept something supernatural or not scientifically testable. And physicists, as they've acknowledged these issues, have come up with some ways to deal with these issues. And one of the big ones, is the cosmic inflation theory, which is the idea that a fraction of a second after the Big Bang, the universe expanded rapidly in 100 decillionth seconds, which that's a 1 with a bunch of zeros before it in decimal. A very, 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 very small fraction of a second. The universe expanded that quickly. And because of it expanding that quickly, it allowed for the irregularities to correct and result in what we observe today. So they kind of corrected themselves as a result, based on what I'm understanding. And this also allows the universe to be in the same place for a fraction of a second, allowing it to be equal throughout in temperature and background radiation, which is a problem we saw with the horizon issue.
Mm-hmm.
And they use this idea to solve the flatness, the horizon, and magnetic monopole problems. And while this idea may have merit, what is noticeable is the fact that additional theories that are much more difficult to test and stretch what science can do are created to fill the holes of the Big Bang Theory.
Mm-hmm.
And we're not in any way trying to say, oh, the Big Bang Theory is stupid and it's false, and we're not trying to disprove the Big Bang Theory. That's not what we're trying to do. What we're saying is there are holes in this theory that scientists have tried to fill with other theories that are in themselves either impossible to test or really hard to test.
Yeah.
And before we get into how God gets into all of this, I wanted to briefly discuss what happens later. What happens at the end? We're talking about the beginning, so what happens at the end? And there's two main explanations as to what happens later. The first is that the universe's expansion will eventually stop and reverse. So the idea is playing off of the universe decreasing acceleration, eventually coming to a stopping point, and then going backwards and shrinking.
Mm-hmm.
And this is essentially called the Big Crunch, which is pretty much a reverse Big Bang, where everything comes back to a single point in space, where everything is in a dense point where we see it at the beginning of the Big Bang. And the idea is that this could lead to another Big Bang, setting the universe into an endless cycle. Mm-hmm. And the other, more predominantly accepted idea is the heat death, which is the universe as a whole reaches maximum entropy or randomness and all matter decays. Because at that point, at a point of 100% entropy, everything falls.
That's referring to, when we're talking about entropy, as you said, that's randomness. This is the amount of disorder in the universe, right? The idea that everything goes to entropy is like the idea of you pouring cream into coffee. You never pour cream into coffee, stir it, and then the cream and the coffee magically separate out. You always see them mixing together. That's the idea that all of the particles of coffee and all the particles of cream are intermixed randomly in your cup and therefore have entropy or disorder.
Yeah, and a little bit more scientific way to think about it is whenever something happens, whenever a reaction happens, because that's what drives pretty much everything, some energy is lost in that process, and it's not replaceable.
Yeah.
Like, we can't get it back. Once it's gone, it's gone.
Yeah, and this happens with everything. This happens with food chains. This happens with you rolling a rock and it breaking. This happens with pretty much everything.
And it's not a lot, but it's a little piece, I guess you could say, a little bit of energy that's lost to entropy. And you can't get it back. And the idea is that eventually all of that energy will eventually be gone. And at that point, matter can't stay together. It all decays and the universe is just gone. So now the question is, how does God play into this? And a big question people have is, could God have used the Big Bang? And my answer to that is he could have. But I would argue that a God-orchestrated Big Bang would not look like the Big Bang of modern cosmology. Now, there is the fine-tuning aspect that we talked about with the issues with the Big Bang. And you could say, well, yeah, God could have, if you're a Christian, you could say, well, God could have been the fine-tuning behind that. And that's true. But I would argue that the expansion of the universe and the other factors used as evidence for the Big Bang may be the result of instantaneous creation by God. We see in Genesis where God says, let there be whatever. I think most Christians agree that that was an instantaneous process, that it happened. As soon as God said it, it happened. Because theologically, what God says will happen, happens.
Yeah.
And I think in creation, that was instant. And when it says, in the beginning, God created the heavens and the earth, if he created the space and the energy right there from the get-go, instantaneously, that could have had a similar result as what's proposed by the Big Bang. with that rapid expansion. Or when he created light, could have been more like an explosion or rapid expansion. And I think it's very possible that that is what we're observing, and that is the result of God's creation commands rather than singularity that modern cosmology holds to. So ultimately, could God have used the Big Bang? Yes, he could have. He could have used it in some way, shape, or form. But even if he did use a Big Bang, it wouldn't have been the way modern cosmology presents it, because the idea of that is the Big Bang itself created everything, or the matter, all the matter that would ever exist, atoms, etc., resulted from that. So yes, God could have used it, but it's highly, highly unlikely that it would have looked like that. So as we kind of begin to wrap up our episode about the Big Bang, there's other points that we have to consider. No matter how you look at it, there has to be something outside of the universe. But there's no way we can scientifically discover what that is. And when I say scientifically, I mean going and finding evidence or observing something to give us an answer or an explanation or a lead. There's no way we can do that. If the universe is in fact expanding, which I think the evidence is strong for, it has to be expanding into something. In other words, where there was once nothing, now there's a distant part of the universe. So what is the nothing that the universe is expanding into, and what's outside of the universe? We don't know. I don't think there's any way to answer that question, but there has to be something outside of the universe. So again, at the end of the day, you must acknowledge something that can't be scientifically tested or supported. And that's either God or something else unknown that humanity won't ever know about. And so ultimately, you're comfortable having faith in the unknown, or you're comfortable having faith in a creator. And I know scientists are very quick, or atheists are very quick to say, oh, we don't have faith in anything. I would disagree simply based on the dictionary definition of faith. And I wanted to look at the Merriam-Webster dictionary for what it says about faith. And it has a nice little simple definition option. We want to consider words in their literal meaning. And this simple definition feature allows us to take words in its literal meaning, which is, according to Merriam-Webster, strong belief or trust in someone or something. So faith doesn't have to involve a deity. It doesn't have to involve religion. It's simply a firm belief in something or someone. And one of the more advanced definitions is a firm belief in something for which there is no proof. And scientists are very quick to say, oh, well, Christianity and creationism has no proof. That's kind of the point. I don't think we're ever meant to prove God's existence. There's a faith component. But in science, there's also things we can't prove, like the dark matter and dark energy stuff. There's no way to prove it.
And yet people hold to it.
They have a very strong belief in this force, mysterious force that's driving what's unknown about the universe. And I say all that to say, again, at the end of the day, you're believing in something either supernatural or something that you can't explain and can't scientifically observe. It does not matter which route you go down. If you want to say there is no God or that there is, you're believing in something that you cannot definitively scientifically prove.
I think that's a good place to stop off for today. Next time, we're going to be covering aspects of the flood of Noah as described in the Bible and what that could look like, what we see as evidence today for the flood, and what could have correlated with it. So we hope you will tune in and join us for that episode.